Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the third aspect relating to free fall. We had our equations and we did the basics related to the equations. We looked at a sum where an object is dropped from a specific height. We looked at a sum where the object is thrown from the ground upwards. And now we have this case where we have an object is thrown upwards from a height of 10 meters above the ground. So if we look at this diagram, as I said, our 3D is very important. So if this is the ground and the object is dropped from a height of 10 meters above the ground with an initial velocity of 5 meters per second, then the object is going to be thrown upwards and then it will come down and hit the ground. And it is important that we have our direction. We take the downward direction as positive. So we have our data that we must write down. Our data is important. We've got our diagram with our initial velocity as 5 meters per second upwards and direction, data, diagram, and direction. That's our 3Ds. So if you look at our data, our V initial is minus 5 meters per second. That's very important because if you don't take that minus into account, our whole sum will be thrown off. And it says here from a height of 10 meters above the ground. I want to know what is the maximum height reached above the ground. Now this is very important that when they ask for the maximum height reached, when you have this falling body sound, we must look at what part of the motion is related here. So in this case, it will be from there to the maximum height. Just to enlarge it, or just right from there, it's going up to maximum height. So your initial velocity here is 5. And as we know, at maximum height, our velocity will be 0. So it's important that we relate our data to the right part of the motion. In this case, it's just initial to maximum height. It is not the whole motion. So your initial velocity is minus 5. Your final velocity in this case will be 0 meters per second. And your gravity always the same. And in our case, I take down as positive, so it will be plus 9,8 meters per second squared. And we have to work at our maximum height, which is your delta y. So if you work this out, we'll see that we have vf squared is equals to vi squared plus 2g delta y. So your final velocity is 0 squared, and your initial velocity is minus 5 all squared, plus 2 is 2, and your gravity is plus 9,8, and your delta y is what we want to find. And if you work this out, we see that our y is equal to 1 comma, just 1,28 meters. So that will be our, let me just double check that for us, 1,28 meters. That will be the maximum height reached. Now the next question is interesting. It says, what is the velocity when it reaches the ground? So many of us will say when it reaches the ground, the velocity is 0. I've seen that misconception, but that's not the case. We are talking about the velocity just before it reaches the ground and then the ground stops it. So what we are looking at is the motion from the beginning till the maximum height, but it doesn't stop there. So our motion in this case is from the beginning till it reaches the ground. So if you look at our diagram, it's that whole diagram from the top till it reaches the ground. So if we have to write our data for that piece, this is very important. Your initial velocity. Now we have a new set of data because we are looking at a different set of motion. In the first case, we had the red, which was only from the beginning till the top. Now we're looking at from the beginning right up to the end of the motion. So your initial velocity is minus 5 meters per second. And we want to work out final velocity, which we don't have. And then we have gravity, which is 9,8 meters per second squared. Now, what else do we have? What we notice is that if you look at this diagram, we are starting at 10 meters above the ground, and you're going up, and then you're coming down to the same height. So this part is equal to this part, and we are looking at displacement. So these two parts will cancel. The going up to the maximum height and coming down to the original height cancels, and then we are left with the original motion, which is 10 meters. So what is important here is that if we take the whole motion, then your delta y will be 10 meters. Now, I'll just explain that again quickly. What we are saying is that if I have to redraw the graph, here's your initial velocity. You came down, and then that cancelled, and then you went further down, and you reached the ground. So you were 10 meters above the ground. This was 10 meters. You went up for 1,28 meters, so it was 11,28, and then you came down, so you can subtract that to come back to 10 meters, and then you went down 10 meters. So this upward motion and this downward motion cancels, so the displacement of the whole object will be 10 meters, and this is a very important aspect to remember when doing the sum. Now if we have to work it out, we take our equations of motion, and we get Vf squared is equals to Vi squared plus 2g delta y. Your final velocity is what we want to find. Your initial velocity is minus 5. Don't forget to square, plus 2 times 9,8, and the displacement is 10. That's very important. And if you work this out, 5 squared is 25, plus 196. Let me just check that again. It will be 2 times 9.8 times 10 and 196. You add the 25, you get 221. You find the square root of that. You see that the velocity is 14,87. The answer we get is 14,87 meters per second. Now what we can do is check this with what we have. But just before I check it, I wanted to show you an interesting diagram. If you look at this diagram, we see that, just to show you the projectile, I made the angle slightly, I didn't make it exactly 90 degrees, but if this is the ball that is thrown, it goes up to its maximum height. When it reaches its maximum, its velocity is 0, and then it comes down and it starts accelerating. As you can see, the horizontal line showing the time intervals to show that it is accelerating. So that's why we see the motion as it is there. So it is important that in our first diagram, we looked at the motion just till that point, and then we stopped. And then for the second one, we looked at the whole motion from the initial stage right till the end, where it is there, just before it strikes the ground. And if we go back to our, sorry about that, if you look at our diagram here, if we just restart this motion, if you look at it, actually it's like this. If you look at this ball here, this is the actual motion that we are looking at. Goes up, goes right down. And then if we just restep it to check our values again, we'll see if as it goes down, we'll see as it went up and it came down to where it was, the ball was at 10, it went up and it came down. We see that the value of the displacement is 9.9, so that it is 10. So we can say that it is 10 there, and then when it hits the ground, we got 14,89. And if you compare it to what we have, We got 14,87. So because of the rounding off value, we see that it is very close. To get a 1,28, I'll try one more time. It was a quick. Okay, I didn't get it, but basically we can see that we are on the right track, where the final velocity is 14,89 meters per second, and we got 14,87 meters per second. So this is a typical sum that shows you what happens when an object is thrown upward and it comes back to its original height and then further goes down past its original height. This is a very important concept, and if you understand this question well, you basically will be able to answer. If you understand the basics of this section, well, you'll be able to answer hopefully exam question if it comes on this topic. Thank you very much for listening.